we are discussing third year basic electronics elective A. In that unit 9 is multivibrators. So, which comes under the semester 5. So, you have to know about that what are multivibrators. These are the electronic circuits which are generating non-sinusoidal waves. So, that here those are the rectangular wave, square wave or sawtooth wave, and it can gives the feedback system and multi-vibrational oscillations between the high and low voltage levels. So, that the signal should be whether it is a high signal or else low signal. So, here which are consist of two cross coupled stages. So, how many types of multivibrations are there? So, there are three types of multivibrations are there. One is the stable multivibrator. So, this you can call it as a free running multivibrator, and another one is the monostable multivibrator. So, this is also called as a one shot multivibrator, and finally, this is the bistable multivibrator. So, we can know about the what are the multivibrators and stable, bistable and monostable vibe. So, here this multivibrator is a multivibrator which is neither state is stable state. So, there are two temporary states, the circuit which can changes the state continuously from one quasi stable state. So, this is very important from the one to another state without any triggering here. So, this is going to be generate the square wave form without any external voltage, and other one is the monostable multivibrator. So, this is also known as the one shot multivibrator, and this is only one state, whether it is the input circuit, the circuit state changed abruptly to unstable state or a periodically, and which the circuit return to its original stable state automatically, and the circuit enables of various width at the requirement moment, and last one which is bistable multivibrator. So, this is also known as a here flip flop, and which is a stable state. Bistable circuit which may be considered as a state indefinitely, and hence it can be used to store binary bit of information. Binary bit means only one bit of information it can store. So, that this you can call it as a flip flop. Flip flop is a temporary, it can act like a register. Temporarily it can store one bit of information, like that here we can able to say that. So, whenever you are applying such a voltage, so the state of the binary is going to be changed here. So, at the occurrence of each triggering pulse, so here which can changes abruptly from the one state to the another state. So, this is used as a digital memory device. Okay. So, let you go for the here in detail picture about the stable multivibrator. So, this is also known as free running multivibrator. So, the basic transistor circuit for a stable multivibrator which may produces a square waveform, a pair of grounded emitter cross coupled transistor, and here true transistors you can able to observe from the figure. You can see that here the figure is that here Q1 is one NPN transistor and Q2 is also an other NPN transistor. Okay. So, here which are biased from linear operation and are operated as a common amplifier with 100% of positive feedback. So, that what do you mean by feedback here? The fraction of the output which is fed back into the input, you can call it as a feedback. So, here from the one transistor into the another transistor, we are taking as a positive feedback. So, that you can able to see that here how the signal here the pulses which are entering at the input stage and how we are taking as a output. You can easily observe from the figure itself. Okay. So, here which runnings multivibrator which has a no stable state, but the circuit has a two quasi stable states of the transistor. Just now we discussed that here transistor Q1 which is in on condition, then the transistor which is Q2 is in off condition. So, that here the transistor if it is Q2 on and it makes the signal has been these states without any external eternal triggering here. So, and also here RC1 RC2. So, from the previous figure you can see that here here RC1 and input section is RC1 and output is RC2. So, here RC1 and RC2 are the which are the collector resistance for the here transistors Q1 as well as the Q2, and here the capacitors of this particular case here R1 and R2 which are going to be providing the base current to the two transistor which are under the saturation region. So, here unsymmetrical condition, what is that here? So, here RC1 which is equals to RC2 as well as R1 equals to R2 and also C1 equals to C2. So, that which are in one half of this circuit are considered to be equal to the other component of the half portion. And here what are the variations of the circuit can be explained. Here the condition is that whenever a power is on, so that here the transistor when comes under the T1 is on and T2 is off. Just now we discussed that in place of T1 and T2 in the circuit which is going to be showing that Q1 and Q2, no need to be confused here. When the Q1 is on, the collector voltage drops near to the 0 volts and the capacitor C1 which is going to be charges through the resistor R2 and applying a negative voltage to the base of the transistor T2 and keeping that here which is going to be conducting the signal, and the capacitor C2 which begins that here charging through the resistor R1 and also which is moving the base of the transistor T1 slowly towards the edge. And here how the action is going to be takes place here when the capacitor C2 is also going to be charges the base voltage of the transistor Q1 which is going to be decreases, and similarly here T1 is cannot stay on condition, and so that in this condition it is going to be off, and T1 it is off here, then the collector voltage rises to VCC, and also here which is right place of capacitor C1 also junction of the positive pulse drives T2 base positive, and then the transistor QT is on condition. So, that here if T2 is on and T1 is off, the cycle is reversal. That is what here in first figure in a stable multivibrator, input is in one direction and output we are taking in as a reverse. So, that how we are getting the reverse means this is the case. Next, here when the two transistors alternatively turns on and off, then the charging and discharging is going to be takes place between the coupling capacitor C1 and C2 here. So, that here back and forth switching continuously indefinitely, and here which is producing the square wave, okay, which between the x and y. Here how you are going to calculate the time period means here the time period capital T which is to complete one complete oscillation here or one complete cycle here. So, that here that means here T1 is on and T2 is also on time, then you can write it down that here the time period capital T which is approximately 0.693 into R1 C1 plus R2 C2, and here resistor which conducts that T1 is on means here here point approximately this value becomes 0.693 into RC. This is a time constant, okay, tau equals to RC like that here. Previously in CR circuit, whether we are going for the CR growth and decay, there only we have been discussed that here time constant tau equals to the product of the resistor and capacitor. There the same equation we are implementing here, tau equals to RC, T equals to RC here, that is approximately 0.693 into RC value, and which can be where we are using this means here in the case of pulse generation and LEDC as well as the generators. And here the graphical representation of this condition which is going to be showing that here the voltage of the transistor T1 which is at VC1, so that it is going to be on means here resistor which can goes to the saturate, and pulling the collector voltage is low near the saturated voltage, that is approximately equals to 0 volts, and other one is that here the voltage which is rising to the VCC and the square wave which is toggling between the 0 to VCC voltage. So, here what is the base voltage means here VB1, which is a more complex. Why? Because of here it is going to be reflects the charging as well as the discharging of the coupling capacitor C2 here. Okay, the voltage VB1 and which is tends downward the capacitor C2 and discharges through the RB2. This voltage is exponentially goes through. So, that from the beside of the figures you can easily observe that what is going to be happening. There are 4 graphical representation which are given to you. So, that how you are going to be calculated the time period and at what conditions we are going to be applying here for transistor T1 as well as the transistor T2, when it is going to the saturation voltages, when we are going to be considering it as a 0 volts or when we are going to be considering as a VCC. Okay. So, here that is the case. Next is that here voltage of transistor T2, which is nothing but a VC2, if it is in on condition, saturation voltage which is near to the 0 volts. Okay. And here how the base voltage of transistor T2, that is the base voltage means VB2, we are going to be calculating, means which is similar to that of the previously we have been calculated in the case of VB1. The same concept you are going to be applying for the charging as well as the discharging of the coupling capacitor. So, during the transistor T2 is in on condition. So, the base voltage of the transistor T2 which can tends towards the discharging capacitor, that is a C1 through the base resistance, that is RB1, and during the transistor T2 is off means here which can be sharp upward spike due to coupling capacitor through the C1 followed by this previous one, and another square wave 180 degrees of output phase with VC1. So, VB2 is also appears like a sawtooth wave. So, here how it is going to be act like a circuit operation means here the transistor never conduct simultaneously here. Okay. So, here you know pretty well about that here transistor which is going to be enhancing the signal, whenever weak signal is going to be enhance the signal here. So, instead of alternative switching on and off conditions. So, here when T1 is on means if it is VC1 is low and T2 is off means VC2 is high. The same principle which is applicable to the here if VC1 is high means here the transistor T1 is in off condition, and if transistor T2 is in on condition means VC2 is low. Okay. So, like that here the charging as well as the discharging is going to be takes place, and here how you are calculating the time period calculation means the oscillations of the time period capital T, which is the sum of the on times of each transistor, that means T1 as well as T2 both you have to consider. So, that capital T equals to T1 plus T2, and this value which gives you the same thing earlier we already derived that here capital T equals to 0.693 into RC. Okay. The same thing. So, that these are the equations you can go for that, and here what is the summary of the waveforms. So, for the 4 waveforms we have been represented which are related to the stable multivibrator. So, here VC1 as well as the VC2 which are the square waves which are 180 degrees out of phase, not in phase, out of phase. So, base voltage is VB1 as well as the VB2 which are exponential waveforms which can gives you a sawtooth wave. Okay, and which can controlling the time here, and what is the output of the collector voltage which can be taken from the collector and which is yielding for this square wave. So, that these are the different waveforms which are to be observed from the diagrams. Okay. Next, monostable multivibrator. So, here a monostable multivibrator, here also two transistors are to be considered, that is a Q1 as well as the Q2, and here coupling capacitors also there, you can easily observe that C1 as well as the C2, and here you can you have to note down that here which is also called as a one shot of a sequential logical electronic, and which can generate an output pulse, and whenever it is going to be triggered a pulse of predefined duration of the circuit, and then it is going to be returns to its stable state. That means a constant signal which is going to be sending, and which can produces no more output until triggering is going to be takes place. So here whenever here there are two transistors are there, NPN transistors Q1 as well as the Q2, and collector load resistors are going to be using here, coupling capacitors C1 and C2, as well as the here base resistors. You can able to observe from the transistors emitter base collector, there we are implementing here the base resistors is R1 as well as the R2. So here negative base voltage is minus VBB, which is the bias of the transistor, and whenever it is needed here for switching, threshold adjustment you can done through this. So here for conducting state means here on state, so that where which transistor is going to be in cutoff condition. So here what is the collector voltage, that is Vc2, which may goes to the saturation voltage, that means here approximately 0 volts, and here the another transistor collector voltage is Vc1, which is approximately equals to Vcc. So here the alternative trigger pulse, whenever if it is going to be applied to it here, the base of the transistor, first transistor Q1, and as well as the here the positive for the transistor Q2, and which it depends upon the here the pulsing, which may turns into the on condition for Q1. So here what are the stable state? Previously we have been discussed the things for the stable multivibrator. The same thing we are going to be following for the monostable multivibrator here. So here the transistor which is in on condition means here where the voltage which can drops across to the saturation voltage we set, and here the capacitor voltage at coupling capacitor C1, and here which is going to be forcing that here the base of the transistor Q2 which goes into the negative. So that whenever the Q2 is in off condition, so the collector voltage Vc2 which may raises up to the Vcc voltage, so that it may remains in the quasi stable state for a duration which is determined by the time constant here RC. Okay. So here stable state when you are going to be observing means here the capacitor C1 which may begins to the charge through the resistor R2. So from the diagram you can easily observe that here, and what is the voltage which is at transistor Q2 which is raises gradually toward the threshold voltage. Okay. So and which becomes sufficiently positive, and whenever Q2 is in on condition again, and which is going to be pulling it into the collector voltage, that which may falls to the Vc2, and coupling via capacitor C2 and to the base of the transistor Q1, and that here the transistor Q1 is in off condition. So thus it returns to the stable state here. Okay. And how we are going to be find out the pulse width means here whenever a saturation T is an on condition means here quasi stable state, which may be given here T on means same thing, that is the same formula which can follows here 0.693 into RC here. That means here which R is going to be considered, resistor R2 as well as the coupling capacitor of the first transistor Q1 is C1. Okay, which depends upon the resistor and capacitor values, and controlling the charging of the capacitor C1. Okay. So here what are the waveforms here, the output pulse at Vc2 or the output voltage V0, which is a single positive pulse and fixed duration whenever which goes to the here and which may corresponds to a low pulse when the transistor Q1 is on conducts. So what are the applications of this? So here the collector coupled monostable multivibrator, which is widely used for pulse stretching, that means lengthening the narrow pulse. Okay. Some pulses which are closed to each other. Say there also, if you are going to be increase the width of the pulsar, there only we are going to be using here. And time delay generation, okay, and pulse width modulation also. Okay, nowadays we are using this technology in so many areas. Okay, so and here timing circuit in digital systems and frequency divisions, missing pulse detection. Okay, these are the so many applications. And what are the advantages of the collector coupling? So this is a fast switching due to the capacitive coupling, and whereas which is a sharp transitions and also simple component count. Okay. Next is the last one is the bistable multivibrator, and here the bistable multivibrator in which the circuit is stable in either state. That means either on state or off state. So it can be flipped, so that by applying an external triggering pulse. So here you can see that here the output voltage, so same transistors have been used here, two NPN transistors have been used, that is a TA1, that is a TR1 as well as the TR2, and here collector resistors are there. From the figure only I am explaining here, you need to follow that here, R1 as well as the R4, and here biasing coupling resistor is R2 and R3. So DPDT, that is a double pole double throw, which is a switch to the triggering of the circuit. So here stable states the same, here there are two stable states, one is the state 1 which is a TA1 is on, that is collector is low near the 0 volts, and output value becomes Q is 0. If T2 is in off condition, means collector which is high voltage, that means which is near reaches the VCC voltage. So that here the output Q bar becomes 1. So you can observe the two conditions here. If here T1 is on means Q 0 output, and if T2 is off means Q bar is 1. Okay. So other state which may comes under the here reciprocal of this, that means state 2, which is transistor T1 is off means which may reaches the VCC voltage, and the output becomes 1 here. 0 means in previous condition is on means output Q is 0. If it is off means output becomes 1. That means 0 means low, 1 means high. Okay, please understand this. And T2 is in on condition means here the collector is low, and whereas the output of the transistor Q bar is here 0. So thus the circuit which may act as a 1-bit memory, and which is storing either logical 0 operation or else 1 operation. So here where we are going to use this means here the triggering pulses for the transistor T1 is on and as well as the T2 is off condition, means here the triggering pulses which are applied to the base of the transistor, first transistor, and turning it to off, and collector voltage which becomes here T1 is raises, that means which is going to be increasing the value. So here the R2, this positive voltage is coupled to the base of the transistor T2, and now the transistor T2 is on means T1 remains off condition. So that here which may flip from the one state into the other state. Okay. So here other one is the here R is coupling action, means here coupling resistors R2, R3 which may provide the positive feedback. Okay. And also here if one of the transistor is going to be on means here it is going to be pulling the other transistor base, and which may the signal is going to be lows, so that which becomes off condition. So that to ensure that here the both the transistor cannot be on simultaneously. So what are the applications which are related to the means which can stores only 1 bit of information here, that is a digital memory which may act like a register here, and also flip flops in the digital circuit. So counters and registers, pulse stretching or signal, and also switching circuits. So here the another last one is that transistor based schemic trigger. So, here if changing the input voltage into a clean digital output, that is whether it is a high signal or else low signal, and which is going to be meaning that it has a two different threshold voltages, so that which can be switches from the low to the high or as from the high to the low, okay, the which may gives the here the triggering from the noise. So, you can easily observe the, you do not be consider the values which are given in this circuit. So, here only observe that how it is going to be connected from the one transistor into the another transistor. Okay. So, whenever input voltage is going to be low means here the transistor T1 is in off condition, whenever it is in off condition means it is no base current at all. So, that voltage at a point A capital is high, and also which can flows through the resistor RA and base of the transistor T2, and also it is going to be turning on, and other transistor T2 if it is in on condition. Previously T1 is in off condition, now it is T2 is in on condition, the output voltage V output which is pulled to the low here previously which is high. So, that whenever you are going to be reading this like this here, you have to compare that previously what happened when the signal is going to be changing here, what is happening. So, that here low input means output is low here. Okay. And also here if it is input voltage is going to be increases, then eventually it is going to be reaches the threshold voltage and transistor T1 turns on. So, that here whenever the voltage is going to reaches T2 is off condition. So, like that here you can have the hysteresis, and where we are using symmetry trigger means here summary of this case means here if it is input low, output is also low, input crosses upper threshold, output is also, or input crosses lower threshold, output is also. So, here you need to know about that how the wave forms of the symmetry trigger, which you can able to understand. So, from this here you can able to understand that what are the multivibrators here, how many types of multivibrators are there here, whenever a signal is going to be giving at input section, what is going to be happening for the output. So, that which may covers for this multivibrator centers. Okay. Thank you.